Hello everyone, my name is Hashita Khelkar and this video is for solution of test 3. So these are the questions. How can multi-factor authentication methods increase the security of authentication compared to single factor methods? So solutions are: multi-factor authentication is a security mechanism that requires users to provide two or more forms of authentication to verify their identity. And here are some ways which can increase the security of authentication compared to single factor authentication. Hmm, First, increased resistance to power attacks. Password attacks. Passwords are a common target for attackers who may use techniques such as brute force attacks or phishing to obtain them. MFA can make it much more difficult for an attacker to gain access to an account even if they have obtained the user's password. Then second is the improved protection against identity theft. Single factor authentication, with the single factor authentication, an attacker obtains a user's password can easily impersonate that user. Means he can easily use the other person identity, uh, and can uh, uh, target an innocent person. And the attacker would also need to obtain the second factor of authentication, such as fingerprint or a single factor authentication or a single factor authentication, and such as fingerprint, which is more difficult to do. Better protection for remote access. SFA is often used for remote access to corporate networks, but it can vulnerable to attacks such as man in the middle attacks. Compliance with security regulations. Many security regulations such as payment card industry data security standard, PCI DSS, and Health Secure Insurance Portability and Accountability Act, HIPAA. These are the examples. And the other question is, what are some advantages and disadvantages of using biometrics for authentication compared to other methods such as passwords or smart cards? So this is the solution. Biometrics are a form of authentication that uses unique physical characteristics such as fingerprints, iris scans, or facial recognition to verify users' identity. And these are advantages and disadvantages. Increased security. Biometric authentication can provide a higher level of security than traditional authentication methods. Second one is convenience. Biometric authentication can be more convenient for users than traditional authentication methods such as passwords or smart cards. Accuracy. Biometric authentication systems are typically very accurate with low rates of false positives and false negatives. Non-repudiation. Biometric authentication provides a high level of non-repudiation, meaning that it can be difficult for a user to deny that they were responsible for a particular action or transaction. And other are disadvantages. Privacy concerns. Biometric authentication requires the collection and storage of sensitive data, which can raise privacy concerns for which can raise privacy concerns in certain situations, like physical characteristics have changed due to injury or illness. And third one is cost. Biometric authentications systems can be expensive to implement and maintain, especially when compared to traditional authentication methods such as passwords or smart cards. And fourth one is integration. Integrating biometric authentication into existing systems can be complex and may require significant changes to existing infrastructures. And the next question is, we have this: how do authentication protocols such as OAuth and SAML work, and what are their strengths and weakness compared to other authentication methods? So this is the answer. OAuth is an open standard for authorization that allows users to grant third-party applications access to their resources without having to share their credentials. So how it works, and strength and weaknesses. The user initiates an authentication request with a service provider such as Facebook or Google. And the service provider responds with an access token that the user can use to authenticate with the third party application. The user provides the access token to the third party application, which can then use the token to access the user's resources on service provider system. And next is the strength, convenient and secure. Users do not have to remember separate login credentials for each third-party applications, and secure users only grant access to their resources on a case-by-case basis. And weaknesses, limited scope and vulnerable to phishing attacks. So OAuth only provides authorization, not authentication. And attackers can potentially trick users so into granting access to malicious applications. And XML security essential markup language. XML based standard है ये exchanging authentication and authorization data between parties. So how it works, the user initiates an authentication request with the service provider such as corporate network. The service provider sends an SML request to the identity provider such as Active Directory. The identity provider authenticates the user and generates a SML assertion. The service provider grants access to the user based on the SAML assertion. Then strength and weaknesses. Flexible SAML supports a wide range of use cases and can be integrated with other different systems. And secure SML uses digital signatures to ensure the integrity of data. And weakness is complex. It is very complex to set up and configure, especially for organizations. Limited support. Some systems may not support SML, requiring additional integration work. These are weaknesses. Then next question we have about trusted computing. What are some potential drawbacks of relying on hardware-based trusted computing sections such as TPMS or secure enclaves? So, hardware-based trusted computing solutions such as trusted platform modules can provide a high degree of security for sensitive data and operations. Potential drawbacks to relying on these solutions are these are limited portability. Hardware-based solutions are often tied to specific devices, making it difficult to transfer, and limited interoperability. Different hardware-based solutions may not be compatible with each other, which can create interoperability issues. Cost. Hardware-based solutions often require specialized hardware, which can be costly to implement on a large scale. Complexity. Implementing and managing hardware-based solutions can be complex. Dependency. Technology. Many hardware-based solutions rely on proprietary technology, which can make it difficult to evaluate their security. And here's how these technologies work. Secure boot is a technology that ensures that only trusted software can run on a device during the boot process. Starting with the bootloader and continue through the operating system and device drivers. If the digital signature is valid, the software is allowed to run, otherwise, it is rejected. Code signing. Code signing is a process that involves digitally signing software code with a unique cryptographic key. It can be used to ensure that software is authentic, has not been tampered with, and comes from a trusted source. And the other question is how can trusted computing technologies used to prevent malware and other attacks on a computer system? This is the question two, which are the technologies working like secure boot and code signing. And the other techniques we have. Organization can prevent malware and other attacks on computer systems, like ensuring that only trusted software runs on the system. Secure boot and code signing can ensure that only trusted software with valid digital signatures is allowed to run on the system, preventing rootkits and other stealthy malware. Rootkeys and other stealthy malware can attempt to hide their presence on the system by modifying the operating system on device drivers or device drivers, providing a mechanism for trust and authentication. By verifying the digital signature of the software, code signing can provide a mechanism for trust and authentication. And the other question is side channel attacks. How side channel attacks be used to extract the information from systems that are designed to be secure, such as encrypted communication or hardware security modules. So here are some few examples of how side channel attacks can be used to extract the information for secure systems. Timing attacks. Timing attacks are a type of side channel attack that exploit the time it takes for a system to perform a cryptographic operation. Power analysis attacks. Power analysis attacks are a type of side channel attack that exploit variations in power consumption by a system during cryptographic operations. Electromagnetic radiation attacks. Electromagnetic radiation attacks are a type of side channel attack that exploit variations in electromagnetic radiation emitted by a system during cryptographic operations. Acoustic attacks. Acoustic attacks are a type of side channel attacks that exploit variations in sound. You can remember its sound imitated by a system during cryptographic operations. And the other one is how counter measures such as power analysis, resistant designs, or randomization be used to mitigate side channel attacks, and what are the trade-offs between security cost and performance. So this is the answer. Here are some countermeasures. So countermeasures work and their trade-offs. Power analysis resistant designs. Power analysis resistant designs aim to reduce the correlation between the power consumption of a system and the cryptographic operations it performs. This makes it more difficult for an attacker to distinguish between the power consumption of the cryptographic operations and the dummy operations. DPA resistant designs is another approach which involves adding noise to the power consumption of the system. And other trade-offs, power analysis resistant designs can increase the cost and complexity of hardware design as well as reduce performance due to the overhead of adding dumbing operations. Randomization. Randomization involves introducing randomness into the system to make it more difficult for an attacker to predict the behavior of the system. And these are two approaches. Use randomized algorithms such as randomizing the order of operations, and another approach is random delays, which can make it more difficult for an attacker to perform timing attacks. Another trade-offs is randomization can increase the complexity of software or hardware design as well as reduce performance due to the overhead of generating and managing random values. Trade-off between security cost and performance must be carefully considered when implementing countermeasures to mitigate side channel attacks. More secure countermeasures tend to be more costly and have a greater performance overhead. So the test 3 is completed. That's it. Thank you.